will join in a few minutes.
Oh, yeah.
Okay. Sure. So let's get started. Yeah. So good afternoon. A few weeks ago, actually, I was a judge at an event called AIconics, and I was judging their NLP and deep learning track. And one of the submission there was from you guys, Abzain, and that's how I came to know about you. And I realized that you guys are doing a fantastic work. And it's my pleasure to be here today.
What was the submission?
What's that
What
again?
was our submission? I didn't know we had.
Yeah, it's overall like what we are doing, and it's very broad, very high level.
Company submission.
Company
Oh,
submission.
okay.
Yeah, yeah. So it's my pleasure to be here today and talk about e-commerce search. I think Kunal is coming. Yes, but- Yeah, just getting started.
Yeah, go ahead.
Yeah. So it's an afternoon talk, it's post-lunch talk. So I thought I would start with a quiz, okay, to help you to stay awake. So I guess we all are familiar with this device. We use it to transfer files and images between computers. Say you would like to buy this device. You go to an e-commerce site, hopefully Walmart.com, and search for this item. So now take a few moments and think about what search query you will put in the search box and say it loud. So, please say it loud so that I can hear it.
Flash drive.
Flash drive,
USB.
USB, ScanDisk, okay. So yeah, I think these are all correct. Customer use many different queries to look for this one item. Not only that, they actually use often misspelled queries to find the same items.
Snap drive.
lot of misspellings in the system. So we have to correct those misspellings and help them to find this item. Let's take another type of example. Say a Walmart customer came in and put in this query saddle in the search box. Raise your hand if you think the customer is looking for this item, horse saddle. Okay, so you think,
Yeah.
I mean, you are not alone. There is some Walmart executives who also thinks for this query saddle, we should be showing the horse saddle. I can imagine those executives are rich, probably they have horses, but Walmart customers are generally not. When they put in this query saddle, they look for this item, bike saddle. So hopefully this two example gives you the challenges we have in e-commerce search. And who am I to talk about that challenges? Yeah, I'm the head of search algorithms at Walmart Labs. I solve this kind of search problems using AI. Few words about Walmart Labs. Like Walmart is the Fortune #1 company. And as you can imagine, there is only one Fortune #1 company. And Walmart is technologically powered by Walmart Labs. And what we do is, as part of our work, one thing we do is we work on all technologies behind the site and the app, like Walmart.com, and also the other subsidiary sites like Jet.com, Henadel.com, etc. Also, we develop all the technologies that is working behind store. And these days, more often than not, we work on omni-channel technologies, which is spanning across the digital and the physical world. One very cool example is the grocery pickup, where the customer can come in and order grocery online. Then they drive up to the store, park their car in a designated area. One of the store associate will come in and put the grocery in the trunk of the car. It's very cool. Customer loves this kind of experience. So is there anyone here who haven't ever shopped at Walmart.com? That's cool. That's cool. That's cool. That's not surprising. Let's move on to the main topic of the talk. So I'll start with like showing the importance of search in e-commerce. Then I will go into some details of how AI is working behind the scene. And finally, I will share my thoughts on the future of e-commerce. So before I show you the importance of search in e-commerce, let's just look at how e-commerce itself is important. So e-commerce started around the year 1995 with the companies like Amazon, eBay, or even Alibaba. And this chart is showing the e-commerce sales in the US as a percentage of overall retail sales. You can see at the beginning, like around 1999, it was very tiny. But since then, it is just a growth story. And today, e-commerce in the US itself is like $500 billion business. and almost 10% of the overall retail sales happens through e-commerce. So e-commerce is big, it is growing, and as you can see, the projection is it will continue to grow. Let's take a quick look why customers like e-commerce. This is a study done by PwC across some 19 countries, 19,000 online shoppers, and the most prominent reason came out that e-commerce has more products or bigger catalog. There are a few other reasons as well, like e-commerce have better product information in terms of item image, item description, reviews. E-commerce offer lower price, better deals. It allows the customer to shop 24/7. Also, the convenience of not visiting a store and getting the item shipped to home. But the most prominent reason was a bigger catalog or a broader assortment to select from. So how big is e-commerce catalog? If you go to a small Walmart store like the neighborhood stores, the number of items there is typically 30,000. If you go to a bigger store like a supercenter, Walmart supercenter, number of items there is 150,000 to 200,000. But the moment you go to a big e-commerce site like Walmart.com, the number of items is not just 10x of the store items, not even 100 times of the store items. It's actually 1,000 times more than what the store has. So Walmart.com today offer more than 100 million items. So the question is, how customers find items from such a large catalog? In traditional retail, the customer talk to the store associate, or the customer themselves take the effort of walking around the store aisles and finding the item. But in the world of e-commerce, customer use the search box to find the item. So search is the primary interface for the customer to find an item. Majority of the customers of e-commerce uses search. And that's why majority of the revenue is driven through search. And that's why search is so important for e-commerce. So even though search is very important for e-commerce, it is technically a very challenging problem. Why so? Because search provides the functionality that an associate does in the store. Customer comes in, provides few keywords, and we already have seen they use many different keywords to find the same item. Sometimes they use the same keyword to find many different items. And every day there are new items coming in, new queries coming in. So we need to solve all these problems. So at this point, you might be thinking that Google does a pretty good job. The web search is doing a pretty good job. There is tons of literature available on how search works. We should be just borrowing some of them and implementing them and we'll be done. But that's not true. Because e-commerce search is very different from web search. In the world of web search, there are queries where everybody will agree that this is the best answer. There is only one correct answer. Here is one example, tallest building in the world. There is one answer, and the search engine shows that answer, it does the best job. Let's take another type of query, like Walmart. I think most people in this room will agree the best answer is Walmart.com, the nearby Walmart stores, or Wikipedia entry of Walmart. So any good search engine should show these results in the top. Let's move on to the world of e-commerce. A typical query there is palm shoes. And in our catalog, we have more than 1,500 palm shoes. Do you think if we look at those 1,500, we'll have an agreement which palm shoe to show on the top? I don't think we'll agree on that because it depends on the customer who is buying, in what context they are buying. And not only that, in an e-commerce site, you will often see this kind of tags like sale, new, bestseller. Those tags actually increases the attractiveness of the item and influences the customer to buy. There's one more thing going on here. If you see this result, I'm showing there are 12 search results for the query palm shoes. Most of the palm shoes here are like between $50 to $100. One of them is $300. Walmart customers typically don't buy such expensive shoes. But what this shoe is doing is having influence on the other shoes. It is making the other shoe look more attractive and sometimes cheaper, and people buy the other shoe more. So in a nutshell, A buying decision is contextual, it is comparative, it is personal, and it can be influenced. So, how do we solve such complex problem? Of course, using AI. So, AI is the brain behind Walmart's e-commerce search, and we use AI and machine learning across all modules of search. Here are a few main modules I'm showing. One is the autocomplete, where the challenge is to select top K queries to show. Then comes the spell correction, which is a language model. We have this navigational module, where we show top K categories to help the customer to disambiguate and narrow down the queries to a particular category. Then we have the query understanding, which is our NLP engine. Then we have the text matching and relevance ranking. That's also machine learned. And finally, the new experience of search and new ways of search, which is the visual search. So the breadth of machine learning used across search is too big. It is hard to cover such a breadth in 30 minutes talk. But to give you a deeper understanding, I thought I'll focus on these two modules. One is query understanding and one is visual search. Okay. So let's start with query understanding. Let's ask this simple question: why we need query understanding? Let's just live with text matching, where we match the query token with the item titles. But then you see there are a lot of problems. Let's take this example, the query lemon. It will match the item lemon fruit. It will match the item lemon tea, lemon juice, lemon squeezer, many different things. The only way we could clean up the results after understanding the query lemon as lemon fruit. Let's take another example. Blue running shoe. If we just do text matching, then there are a lot of blue running shoe earrings which will show up on the top. Only after when we started understanding blue running shoe as shoe, we could clean up the results and provide a better experience to the customer. So what exactly is query understanding? So query understanding takes the query and tags the tokens of the query with different product attributes. And in this example, the Black & Decker is the brand, Coffee Maker is the type, and the price is between $0 to $50. And overall category of the query is home. So that is the output of the query understanding. And let's see how do we build a query understanding system. Let's start with a very strawman approach, where we will rely on just string matching and dictionaries. So in this example, let's say we have two dictionaries. One is gender dictionary, one is brand dictionary. And we use that to do the query understanding. So the way we will do it, once we get the query, we'll take each token of the query one at a time. And if the token is present in the dictionary, we'll tag this token with the corresponding dictionary. So the example is Pioneer Women Bedding. So now the women token is in the gender dictionary, so we call it a gender. Another example is NB diapers. NB is in the brand dictionary, so we call it brand. But both of them are wrong, because Pioneer Women is a brand and NB is newborn, which is the age group. So the strawman approach has the complexity. It cannot really resolve the ambiguity of the words. So the approach we use is the AI approach. And overall architecture is very simple. We have a bunch of training data, and we train a deep neural network to predict the tags of the token. More specifically, this is what we have. This is what the training data looks like. We have a lot of queries where the tokens are tagged with different attributes like color, gender, brand, product type, age value, age unit, etc. So we have this bunch of training data. Then we use a deep neural network model, in particular BiLSTM, and then finally on top of that, we have a CRF to do the joint optimization. So what are the advantages of using this AI approach? As you can see, this is end-to-end. We don't have to maintain a dictionary. No feature engineering is required. So this approach also handles the ambiguity much better. In the example of Pioneer Women, it can understand it's a brand, not a gender. It has a better generalization capability. What that means is it can understand Sony as a brand in the query Sony TV, even if the Sony TV is not in the training data. It learns such patterns from other queries like LG TV, Vizio TV. It works with the misspell queries. We don't have to have a special handling of the misspelling. And also it can handle reflexivity, like Sony TV or TV Sony, it can understand both. What are the cons of this approach? It requires manually curated training data. Particularly in this case, it could be costly, it could be time consuming. But in our experience, we have seen that 10K training data is good enough. It's a good start. So that's not too bad. Also, it lacks the interpretability.
Do you think 10K is enough? Or it's
I would say it's good enough start, not enough.
given, like the kind of number of products that Walmart sells and how the cardinality of data is so high?
So, you have to break the problem. 10K is not enough to cover all the corner scenarios, but let's say you want to cover your major brand, you have to cover your major patents. So you have to focus. The distribution of the query is, the overall number of queries is pretty huge, but there is a power law going on. So as long as you can focus on certain segment, I think 10K is a good enough start. Okay. So that's all about query understanding. Notice one thing, the query understanding is good when there is a query. When the customer is given us a query, if you can understand the query, we can provide a better experience. But there are a lot of scenarios where customer is unable to provide a text query. Let's think about that we want to buy this item. So how do you specify this item? Is it a sofa or love seat? Is the color is blue or teal? Is the fabric is chenille or cotton? What about the style? Is it mid-century and modern? I'm not quizzing you, it's hard. Most customer doesn't know the style. So there are many categories like clothing, furniture, home decor, where customers have detailed preference in terms of color, style, material, and they find it really difficult to put it in a text query. So we believe in those categories, in those domains, search by image or visual search will provide a better experience to the customer. And I think in this room you know that visual search is enabled by a tremendous progress in computer vision. So back in 2011, the computer has to understand and the object in an image, particularly in the ImageNet dataset, the error rate would have been very high. So it was like 26%. But like fast forward 5 years, the progress was so much that the error rate came down to 3%. If you are thinking like how human does in the same data set, what would be the error rate of human? It's actually worse for human. Human does worse in understanding the object in that particular data set. So with this much progress in image understanding, we are able to bring up visual search for our customer. And let's look at the architecture of the visual search we use. That's actually very simple. At the heart of it, there is a deep neural network, Inception ResNet V2 in our case. And the deep neural networks takes an image as an input, and it outputs the signature on the embeddings, which is the real vector. We index those embeddings in the embedding index, and at the query time, when the query image comes in, we pass that query image through the same neural network, get the embedding, and then we do an approximate nearest neighbor search in the embedding index. So although the overall architecture is very simple, but tuning the model, scaling the model, it's actually challenging. In particular, we are facing the challenge in these three areas. Our model is pretty accurate on the professionally taken photos, particularly the catalog images, because that's where the model is trained. But it is harder for the user taken photo. When somebody takes a photo, there are a lot of background colors, and those makes it pretty hard. So this neural network, the way it is designed, they're very good at understanding the object in the image, particularly the product type. But when it comes to the attributes like the style, the color, the material, the accuracy is poor. Also, scaling this model in a large data set, like hundreds of millions of products, particularly when the catalog is changing fast, new items are getting added, old items are getting removed, we find it challenging. So even though all these technical challenges are there and we are working on it, we are actually able to put together a reasonable version and live testing it on henryl.com. So I encourage you to go to henryl.com and try out our visual search. You will see a camera icon next to the search button, and once you press that, our visual search is triggered. But just to show you a demo, we have put together a video. I'll just play that video here. So So in this video, one of our fine engineers is just walking with his phone, and as soon as the phone detects an object, it calls our Visual Search API with that object, and that triggers our Visual Search, and we are showing the search results. And as you can see, it's not perfect, but it's doing a good job. So that's it. I think that's on the hopefully these two areas, the query understanding and visual search, gave you some detailed understanding of how exactly we are using AI and machine learning in e-commerce. Next, I will move to the future of e-commerce. I'll share my thoughts there. But before I do that, I'll take a step back and we'll look into how search evolved in e-commerce. So here is a screenshot of Amazon website and Walmart.com website from its early days. I mean, do you see the search box there? It's there, because search is always important for e-commerce. So it is always there, but you can see it is very tiny little there. So it was very hard to get it right. Search is a hard problem. It was there, but it's intentionally kept hidden. So fast forward 15, 20 years, now if you look at any e-commerce website, what you will see, the search is in the most prominent location in the website. So as I've shown you earlier, e-commerce has a tremendous growth over this past 15, 20 years. But you can see within e-commerce, the importance of search has grown even faster. And I think the future is even more exciting. To imagine the future of e-commerce search, I use this image to visualize what will happen. So in this image, this lady is doing the search very seamlessly using gesture and voice. And the results are shown in a personalized way, particularly how she would look on those dresses. In more concrete terms, I see the image and the voice search will become more mainstream. Omnichannel search will also become very popular. Omnichannel search is search across stores and online. Conversational commerce will take off, and AR and VR will redefine search and e-commerce in general. So at Walmart Labs, we always like to stay ahead of the game, and we also have a few things going on here. I already showed you our initiative on the visual search, and then there are a few other initiatives from a few other teams, like the conversational commerce we roll out in the name of Jet Black. There is some VR-based initiative, we call it V-commerce. So with this, I leave it here, and hopefully you will agree with me that search is a very exciting use case of AI, and the future is even more exciting. Okay, so with this, I'll end my talk, and thank you for listening.